Hey, welcome back to Mr. P Helps with Precal. This is Unit 1, Topic 1, SLT, or Lesson 10. As we are once again continuing our discussion about inverses. So for the warm-up, it says find f of g of x and g of f of x. So we have our two functions right here. It's going to take a little bit more work than the one we did in the video. So I'm going to take all of this and plug it in for x's here to find f of g of x. So this is f of g of x. Alright, so I'm going to take all this, plug it in right here. So I put 1 over x minus 1 as the numerator, and then 2 times 1 over x minus 1 minus 4 in the denominator. Okay, so first thing I would notice is I can just multiply 2 times 1, which makes this a 2, so I'll just change that. Now, if I multiply both top and bottom by x minus 1, so that cancels here, it basically cancels here, and then multiply by x minus 1 here. So you're left with just 1 as the numerator, and you're left with negative 4 times x, and then plus 4 over there. Okay, so basically, so we now have a rational function. So since we know it's a rational, it's 1 over negative 4x plus 4, so we know it can be, a domain is all real numbers, except the denominator is not allowed to be 0, in which x is not allowed to be something. So I'm going to take that bottom, and I'm going to say it can't be equal to 0, and that gives me this, and then divide both sides by negative 4, and tells me that x is not allowed to be 1. So now I'm going to do the same thing for g of f of x, which means I'm going to take all of this and plug it in for this x right here. So 1 over, that's going to be x over 2x minus 4, and then minus 1 right there. Okay, got to get rid of this denominator, so I'm going to multiply everything by 2x minus 4. So we have 2x minus 4 on top. This gets canceled, so it's x minus, so it's negative 1 times this, minus 2x plus 4. Okay. So x minus 2x is negative x. So we really have, this is just becomes negative x plus 4 at the bottom. Once again, denominators can never be 0, so negative x plus 4 cannot equal 0. Negative x equals negative 4, which means x cannot be 4. So domain is a set of all real numbers in which x cannot be 4. Okay, so relating inverses composition of functions. Recall from the last class, graphically we have these two inverses, this purple and this green, which are perfect reflections over the dotted line. So we find out that no matter what x you put in for the first function, whatever answer you get, you put in for the second function, you're going to get the exact same x you put in to begin with. So the inverse, f of the inverse x is always going to be equal to x, or whatever you put in for the input, and the inverse, the f inverse of f of x is always going to also equal x. So it works both ways. No matter what input you put into one, and you take that output and put into the other one as the input, and you're going to get the same output as you started with the input. Yeah, if you can follow all that in words, that's basically what it means. We can verify algebraically a two function inverse of each other by using this definition. So we know that it's basically the same x and y's inverses, flipped around. Find the inverse of the following, then verify algebraically that your answer is correct. Okay, so kind of similar to what we did the last one, we're going to make a t-chart. So the first thing you would do using order of operations is x squared, and then you would multiply by 5, and then you would subtract 3. So the same operations done backwards, and the opposite operations would be plus 3, and then divide by 5, and then square root. So then that basically tells us the inverse, because this was 5x squared minus 3. The inverse is x plus 3 divided by 5 and the square root of that. Okay, so that's the answer that we learn how to do in Algebra 2. So let's find algebraically whether or not that is correct. So I'm going to change this to y equals f of x squared minus 3, and then switch the x and the y's around, because that's basically what inverses are. So x equals 5 times y squared minus 3, and now I'm going to solve for y. So first I'm going to do is add 3 to both sides. Gives me x plus 3 equals 5y squared. Divide both sides by 5, and I got x plus 3 divided by 5 equals y squared, and then square root of both sides, and ladies and gentlemen, yes, we have the exact same thing. We end up, these cancel out, so you end up getting y equals x plus 3 divided by 5 and the square root of that, which is the exact same thing we had gotten doing the other way. So these are inverses, and we have proved it algebraically as well. All right, so we're going to decide, we're going to do the exact same steps for this question. What we're going to find out, and I'm just going to kind of give it away right now, is that they're not going to be inverses of each other. Algebraically, you're going to get something different, which means they're not technically inverses of each other. So verify algebraically the inverses of each other. So let's see. Find the inverse. So let's do that first. So if I was doing the steps using order of operations, I'd do x squared first, and that would multiply by -1. I would have to multiply this by this negative, and then I would add 4 to it, and then do the square root. So the inverse steps of that would be squaring something first, and then subtracting by 4, and then divide by -1, and then doing square root, because that's the opposite. So if I build that, so that's x squared minus 4 divided by -1, and then square root of that. All right, so if I do the same thing over here, I should get the exact same answer. So y equals square root of 4 minus x squared. Flip the x and y's around. Square root of 4 minus y squared. Next thing I would do is square both sides. So I get x squared equals 4 minus y squared. Subtract 4 from both sides. So I've got x squared minus 4 equals -y squared. Divide by -1, kind of like we did over here. So now we've got y squared equals, and I'm going to leave it in this format, x squared minus 4 divided by 1, and then square root of that cancels. Y equals x squared minus 4 divided by -1. Okay, so I take it back. So we do have the exact same thing. I thought this was going to come out differently, and it does come out the same. Yeah, square root of. Okay, so let's try the other one. And let's try erasing this first. There we go. So f of x equals 1 over x minus 1. So same steps over here. So we've got 1 over x minus 1, which means the first thing I would have to do is, using order of operations, I would have to take that number and subtract 1 from it, and then do 1 divided by that x. Okay, so our steps for solving this is not the same as what we would normally do. So y equals 1 over x minus 1. Switch them. You get x equals 1 over y minus 1, which then I want to get y by itself. So I'm going to have to get rid of that minus 1. So the easiest way would be to multiply both sides by y minus 1. So that gets rid of these times y minus 1. Distribute. So I have xy minus x equals 1. I can then I can add x to both sides. So I've got now xy equals 1 plus x, and divide by x, and I've got myself y equals 1 plus x over x as the inverse of this function. Alright, so graphically, how can you check the inverse of this function? In other words, so we know it's a inverse if it's a perfect reflection of the y equals x, and basically if it passes the horizontal line test, so if the original function passed the horizontal line test, which this one does not, then it's not going to pass the vertical line test on the inverse. So that you know the inverse is not a function when the original function does not pass the horizontal line test. And I'm going to have to stop right there. Thanks again for watching. Have a great day.